11, sequences in series. And 11.2 is all about arithmetic sequences in series. 11.3 is now the geometric one. Just remind you, geometric is all about multiplying and dividing. You have the common ratio instead of the common difference. So our homework comes 18, 23, 35, 42, 44, 51, 52. These ones are alike. So, well, 51, 52 are alike, 42, 44 are alike, and then these are each individual types of problems. Let's open up. So 11.3, I can use geometric sequences and find the sums of geometric series. We're not going to do this first example. It's kind of weirdly written and doesn't help us out. But here is the base formula. It is given on any sort of assessment. Here's our nth term. Here's the first term. R is the common ratio. And then n is, and here they have it as any natural number. It's just the term number we are looking at. So the term, we'll just call it the term number that you're looking at. All right. So that's kind of the basis of that formula. But now my first example I'm going to give you, we'll put it way up here in the left corner, is just find the first 4 terms of a geometric sequence where A1 equals 2 and R equals 4. Now, right, so if A1's 2, so our first, we're going to answer this, the answer. One, you could use this formula like we did with arithmetic, or you can just go, alright, so I have 2 I start off with, times by 4, 2 times 4 is 8, okay, times by 4, okay, it's 32, and then times by 4, and I get 128. Alright, so it's just like for the first 4 terms of arithmetic where you would add each time. This time you're just multiplying by 4 each time. For most times with the first 4 terms, especially if you're given the first term and the common ratio, I find this way easier. You can use this all you want to find each part. It's just this one's a little bit quicker. Okay, and the second example would be something like find the 10th term where A1 equals 15, R equals -2. Alright, so we want to find the 10th one. So we're looking for A10, right? The 10th term, A with the little 10, equals A1 is 15, our R is -2, and then our N, right? N is the term number. So we're looking for the 10th term. So N equals 10. So we have 10 minus 1. So now we have 15 times -2 to the 9th. You have to do the exponent first, so you do -2 to the 9th, and you should get -512. Just check to make sure that's correct. Yep, -512, and then you multiply that by 15, and you get the 10th term equaling -7,680. All right, so it's a lot of it really just mirrors arithmetic. It just, you have this common ratio instead of common difference. Part 3 is this B, write an equation. It's just like for the arithmetic. First off, we need to know what is our first term. All right, well, that's 0.5. Our common ratio, how do I go from 0.5 to 2? I times it by 4. Right, and if you weren't sure how you were going to get that, you could even look from 2 to 8, or 2 times 4 is 8. Okay, that works. You could also always do, right, what's the math actually behind here? It's 2 times what? So we'll just use x equals 8, and then you can divide by 2, right? That's the classical mathy way of doing it. Now we're just going to play everything we know. I'm not going to have anything for the nth term. this is equal to, my first term is 0.5, my common ratio is 4, and then we have the n minus 1. Again, you were just writing the equation, so now you have an equation that you can plug any n in for, right? We could look for the fourth term, when we plug 4 into here. We're looking for the second term, you plug 2 into here, whatever you want to do. All right. So part 4 now is geometric mean, kind of like arithmetic mean. This time, obviously, you're going to be working with a common ratio. So our first thing we need to do is, if they don't give us an n, we need to figure out, okay, what is my n going to be? And to do that, it gets a little bit trickier. How can we figure out that our n is 5? Right? And what I mean by that, three. This is the giveaway to help us. So here's 3 geometric means between, and then here's 2 other ones. Those are 2 other terms. So we're looking for 3 plus 2, 5 terms total. All right. So it's going to kind of give you this, find the 3 geometric means. So that's where this 3 comes from. And then there's 1 and 2 right here. All right. So once we have n, kind of works out a little bit nicer now. And we have our classic formula. The nth term equals the first term times the common ratio, n minus 1. All right, well, what's our last term? 1,250 equals our first term is 2. We're looking for the common ratio, and then our n we said was 5. We have 5 minus 1. And then have 1,250 equals 2r to the 4th. Well, now I want to get rid of this 2 here. This is kind of like solving for this r, so I'm going to divide by 2 here. So now I have 1,250 divided by 2 is 625 equals r to the 4th. I 4th root both sides. R was going to equal 5. So my common ratio is 5. So now I start with 2, and I have 3 missing ones. I'm going to end with 1,250. Right? Now how would I get this one? 2 times 5 is 10. 10 times 5 is 50. 50 times 5 is 250. And then that times 5 will get you to 1,250. All right. So biggest thing, first, find your n, and then you're going to go find r. All right. And you just write the steps right there. 1, find n. 2, find r. All right. And then the last couple parts. This is kind of that second day stuff. Find the sum of the geometric series. You're either going to use, depending on what you're given, and you're always going to have an r, you're always going to have an n. It just depends on, do you have, well, no, maybe not always have an n, but do you have a first term and an n, or do you have the first term and the last term? Which one did they give you? You need to be able to see that and then choose either one. All right, so for this first example, we have an a, the first term, we have an n, so we are going to have to use this top one. So you have Sn equals a1 minus a1r to the nth divided by 1 minus r. And r is not negative 1. That's what this little thing says. It's just if r, like r can't equal 1, we know it doesn't. Because if the common ratio is 1, we don't really have a series. It's just going to be whatever number times 1 is, it's going to be itself, and it's going to continue to multiply by 1. Doesn't matter. But now we have the first term, so we're going to plug the first term in. So you have 2 minus 2 times 3 to the 10th, all divided by 1 minus 3. Now we're going to do a little bit of simplifying here. So we have 2 minus 2, 3 to the 10th is 59049, and that is all being divided by -2. And I'm going to bring this up here now, and now we have Sn. Now I'm going to do this multiplication between the 2 and the 59,049. So now I have 2 minus 118,098, all divided by -2. Do this subtraction here first. So I have -118,096 divided by -2, and then the sum is going to be divided that by -2, 59,048. So it's just kind of a lot of simplifying. Once you put the numbers into the correct formula, it's just a lot of simplifying from there. We won't have to worry about that. This is kind of part 5. And then I have one last example for you. Flip over. And it just goes off of find the first term in the geometric series for which Sn equals 13,116, n equals 7, and r equals 3. So first things first, we have an n. We're looking for the first term. We're going to have to use that first formula again. And again, that is Sn equals the first term minus the first term times r to the nth divided by 1 minus r. You're then plugging for Sn the 13,116 equals, we don't know what the first term is, so we're just going to leave them like that. And then you have r is 3 to the 7th, all divided by 1 minus 3. So on the left side, that just drops down. You now have a to the first minus a to the first times 2,187. This is all divided by -2. And now, that's where I might just leave you off. I want you to try to see if you can solve this for me. Right, your first step would have to be multiplied by -2 on both sides to get rid of this. So you should get -20. Oops, sorry. That should be, there should be an extra 1 there. There we go, 13,000. So it should be -26,232 equals A1 minus A1 times 2,187. All right. Your final answer, you should get 12, is the first term. The first term. And one look quick and think about what we did with logs here. Right, there's a 1 right here, and we can actually take out an A1. Have something like this then. And I'll let you see if you can figure out how to get to 12 from here. All right. But that is the last section of Chapter 11. Yes, there is a lot, but a lot of it mimics just what arithmetic series are. They're just the common ratio instead of the common difference.